In this video, we'll be discussing section 3.2 from chapter 3 of S1, and we're discussing outliers. Okay, now back in chapter 2, when you were discussing, when you were introducing the range, measures of spread for our data, such as range, interquartile range, and so, we did discuss the effect that extreme values could have on the mean and also the spread of a data. Okay, if you consider the range, okay, and the range is also affected by extreme values. Now, outliers is the term in statistics that you use to refer to extreme values. Okay, so an outlier is an extreme value that is not fitting in the overall pattern of the data. Okay, now in this section and in S1 examination, you might have to calculate the outliers given a particular data set. Now, the exact calculation formula might differ. Okay, so let's say that if you have a particular data set, okay, you have some particular data set, okay, and we get to know what the interquartile, what the lower quartile and the upper quartile is. Okay, we have the median in the middle. Okay, if we know the lower quartile and the upper quartile, in that case we can find out whether we have any outliers. Okay, using the formula Q3 plus K times IQR, where IQR is your interquartile range. Okay, so if some values, okay, and depending upon the value of K, okay, your K might differ, but commonly K is equal to 1.5. okay, usually most of the time you'll notice that K is equal to 1.5, but that does not mean that K is always 1.5. okay, you need to follow what the question says. Okay, if you have some values which are greater than Q3 plus 1.5, in that case those values will be considered outliers. On the other hand, over here, if you have values which are less than Q1 minus K times IQR, okay, in the case of K equals 1.5, if you have values Q1 minus 1.5 times IQR, okay, in that case values which are less than that boundary are going to be considered outliers. Okay, in a similar fashion, okay, in this case you're using Q3 plus K times IQR, Q1 minus K times IQR, where the value of K would be given to you in the question. Okay, in the other example, in the other case, okay, we could consider the mean x bar, and we could consider x bar plus K times the standard deviation, x bar plus K times the standard deviation. That would be the boundary, the upper boundary. Anything beyond that will be considered outliers. And we also have the lower boundary, x bar minus K times the standard deviation, and over there we have the lower boundary, and anything below that will be considered outliers. Okay, usually when you use sigma, okay, when you use the mean and the standard deviation, okay, the common choice used is x bar plus 2 times sigma, or x bar minus 2 times sigma. Okay, sometimes they also use 1.5 times sigma, but again, these are just two examples. Okay, it does not mean that K is always 1.5 for the quartile method and K is always 2 for the mean standard deviation method. Now let's consider example 3. In example 3, we have an example that uses the first method, okay, the quartile method. Okay, and over here they have given us the blood glucose level for 30 female. Okay, so we have n equals 30, okay, 30 female, and we have the results have been given. Okay, the blood glucose level is in millimole per liter. Okay, blood glucose level, let's say it is G, which is in millimole per liter. Okay, let G be the blood glucose level. Okay, and the data has been given in ascending order, so it will be easier for us to analyze this data. The question says that an outlier is an observation that falls either 1.5 times the interquartile range above the upper quartile, or 1.5 times the interquartile range below the lower quartile. So this is the rule that they are using. Okay, greater than this or less than this. Okay, so in this case we have greater than Q3 plus 1.5 times IQR, or less than Q1 minus 1.5 times IQR. Okay, In this case, k is 1.5. That does not mean the k is always 1.5. We need to follow what the question says. In this case, k is 1.5, and they're asking you to find the quartiles and the outliers. Okay, so notice that we have got 30 data values, so n equals 30. In that case, okay, to find the quartiles, first let's talk about the lower quartile. The lower quartile will be q1 equals 30 by 4. 30 by 4 is equal to 7.5. Okay, now notice that this is discrete data and not continuous data. Therefore, 30 by 4 is 7 by 5. In that case, round this up, we get the 8th data value. Okay, so the 8th data value is going to be your lower quartile. Okay, the 8th data value is going to be your lower quartile, and in this case, the 8th data value is refer to the values on page number 35, example 3. Okay, we have 3.2. Now you can write down the unit, millimole per liter. Okay, next you have q2. Q2 is the second quartile or the median. Okay, q2 and the median are both the same, refer to the same thing. Okay, so q2 is the median. Okay, for this one, 30 by 2 is equal to 15. This is the whole number, therefore we need to consider 15 and 16 both. Okay, so we have the 15th plus the 16th by 2. The 15th and the 16th are 3.8 and 3.8. Okay, so 3.8 and 3.8 are both equal, therefore the answer is simply 3.8 millimole per liter. Okay, finally we have the upper quartile q3. Q3 is equal to 30 into 3 by 4, which is 22.5. Since this is not a whole number, in that case round it up, we get 23rd value. Okay, and the 23rd value would be 16, 17, 18, 19, 20, 21, 22, 23, which is 4.0. Okay, so read the data, you'll get this is 4.0 millimole per liter. Now in the second part of the question, they're asking us to find out if there are any outliers. Okay, the rule for outliers is this. Okay, so let's first find out the IQR. Okay, so IQR is equal to q3 minus q1, which is 4.0 minus 3.2, which is equal to 0.8. Okay, so IQR is q3 minus q1, 4.0 minus 3.2, which is 0.8. Now let's find out the lower boundary. The lower boundary is q1 minus 1.5 times IQR, which is 3.2 minus 1.5 times 0.8, which is 2.0 millimole per liter. Okay, 2.0 millimole per liter. Finally, we have the upper boundary. The upper boundary is q3 plus 1.5 times IQR, and that is equal to 4.0 plus 1.5 times 0.8, which is 5.2 millimole per liter. In other words, okay, anything that is below this or above this is going to be considered an outlier. So anything less than 2.0 would be considered an outlier, okay, an extreme value, or anything greater than 5.2 would be considered an outlier or an extreme value. And from our data, we can see that the lowest value is 1.7. The lowest value is 1.7. Therefore, 1.7 is definitely an outlier. Okay, so 1.7 millimole per liter is an outlier. Do you have any other outliers though? After 1.7, the next value is 2.2. 2.2 is higher than 2.0, so it is not an outlier. Okay, and the rest are all okay. The highest value is 5.1. 5.1 is less than 5.2. In that case, it is not an outlier. In case if we had 5.5, in that case 5.5 will be greater than q3 plus 1.5 IQR. Therefore, that will be considered an outlier. In this case, we just have one outlier, 1.7 millimole per liter. Okay, so in this case, the rules can differ. Okay, you need to follow the specific rule that is given in your question. In this case, we have been given q3 plus 1.5 times IQR and q1 minus 1.5 times IQR. Less than this, greater than that, in that case it is an outlier. Find q1, q2, q3, find IQR, find the lower limit, find the upper limit, and then compare the lower limit and the upper limit, the data with these two limits, and then find out if there are any outliers. Now, in example 4, on page number 36, they have given us the length in centimeter. In example 4, on page 36, they have given us the length in centimeter of 12 giant African land snails. Okay, and again the data has been given in ascending order. So we have n equals 12. Okay, that's the total number of data points given. Okay, the data is given in ascending order, and in part A they have given us calculate the mean. They're asking us to find the mean and the standard deviation, given that sigma x equals 252 and sigma x squared equals 5468. So sigma x is given as 252, sigma x squared is given as 5468, and they're asking us to find mean and standard deviation. Okay, so to find mean, we just need to use the formula x bar is equal to sigma x by n, which is equal to 252 by 12, and as you calculate this, you'll get 21. Be careful with the unit is going to be centimeter. Okay, the mean does have a unit, okay, centimeter, because we are having the length of African giant land snails in centimeter. Now the standard deviation, to find the standard deviation you need to first find the variance. Okay, the variance is going to be sigma squared is equal to sigma x squared by n minus sigma x by n the whole square. Okay, so this is back from chapter 2, sigma x squared by n minus sigma x by n the whole square, and that is equal to sigma x squared is 5468, so 5468 by 12 minus 252 by 12, which is 252 by 12 the whole square. 252 by 12 is 21, so you could just write 21 square also, that would still be okay. Okay, calculate this, we get let's leave it here, 44 by 3. This is the variance, and in that case sigma is going to be the square root of this answer. Okay, square root of the variance, then in that case this is going to be 3.83 centimeters. Okay, 3.83 centimeters. For variance it is going to be centimeter squared. Okay, for standard deviation it is going to be simply centimeters. Alright, now in part B they are giving us, okay, this is for part A, mean and the standard deviation. In part B they are asking you to find the outlier, and the rule they have given us is that the outlier is such that it lies beyond plus minus 2 standard deviations from the mean. Okay, so the outlier lies plus minus 2 standard deviations from the mean. In other words, okay, it is lying either greater than x bar plus 2 sigma or less than x bar minus 2 sigma. Okay, so if it is greater than x bar plus 2 sigma, or if it is less than x bar minus 2 sigma, in that case it is going to be an outlier. So that's the rule in this particular question. Okay, follow the specific rule that is given in the question. In this case they are asking beyond plus minus 2 standard deviation from the mean. In that case it's an outlier. So in that case the question says, are there any outliers? We need to find out the boundaries. The upper boundary is going to be x bar plus 2 sigma is going to be 21 plus 2 times sigma. Okay, so use your calculator to calculate. You'll get this is 7.66, which is 28.66 centimeters. Okay, so that's your upper boundary. The lower boundary is going to be 21 minus 2 sigma, which is 7.66 again, and in this case you get 13.34 centimeters. Okay, so anything less than 13.34, anything greater than 28.66 will be considered an outlier. Okay, now the lowest out of all the data points given, the lowest value is 17, which is higher than our lower boundary. So in that case we don't have any outliers on the lower end. The highest value given to us is 32. Okay, the highest value is given to us is 32, which is greater than the upper boundary for outliers. Therefore that 32 centimeter is definitely an outlier. The next value after 32 is 24. Okay, the next value after that is 24. 24 is less than 28.66, so it is, since it is less than, it is not greater than this. Okay, it is not an outlier, so we do have only one outlier. The rest is all the rest are all okay. So in that case 32 centimeter is an outlier. Okay, so now one thing in the following, in after example 4 on page 36, they do have a discussion about what exactly you need to do with outliers. Okay, now just because there is a particular value that does not fit our that is deemed as an outlier because of the rules that we determine. So let's say that in this rule we had minus 2 sigma plus 2 sigma, and for that reason we considered 32 centimeter to be an outlier. Okay, now do we need to clean the data? Okay, cleaning the data means you remove. Do you need to clean the data? Cleaning the data means you need to remove any anomalies. Okay, now just because a data point is an outlier does not mean that it is an anomaly. Okay, maybe in the case of the way they have explained it, in the case of African land snails, even though 32 centimeter is an outlier, most of the snails are between 17 centimeter and 24 centimeter, which is a very small range. Okay, if you notice, okay, between 17 and 24. So most of the snails are between 17 and 24. But even the 32 is an outlier. Okay, according to our rules over here that is set up. Okay, these rules made 32 to be out of the range. Okay, therefore 32 is going to be an outlier, but that doesn't mean that 32 is an anomaly. Okay, maybe there are some rare African land snails which are 32 centimeter in length. Okay, so in that case it will not be an anomaly, but it will be just a rare exception. Okay, it's still an outlier. Okay, so just because an outlier doesn't mean that it is an anomaly. Okay, an outlier is not necessarily an anomaly. Okay, now if you do have anomalies, okay, and let's say because of some you were collecting data, let's say that if you're collecting data on a field or from some experiment and while trying to insert those writing those down those data, or while trying to insert those data into some software, let's say in Microsoft Excel or some other software, you made some typing error or some typos. Okay, and you do have some data that are definitely outliers and they do not make any sense. Okay, in that case you would consider them to be anomaly and you'd remove those data points. Okay, remove those data points before you actually process the data any further. That particular process is called cleaning the data. Okay, now when you remove a data point, to remove a data point you need to be able to justify it. To remove an anomaly you need to justify it. Okay, you cannot simply just remove the data points by saying that it is an outlier. Okay, just because it is an outlier doesn't mean that it needs to be removed. Okay, so let's say that if we have using the same example that they have given over there on page 36, at the end of page 36, let's say that you have people in a birthday party. Okay, where a parent, okay, is has invited a lot of his a lot of friends of his son or daughter to the birthday party, and most of them are children. Okay, no parents has come except for no other parent is there at the party. In that case, let's say that the ages of the people at the party are recorded. In that case, let's say if all of them are children, in that case you have 6 6 6 7 7 7 7. Maybe they're all from the same class, that's why. Okay, 7. And finally we still have, since the parent is still attending the birthday party, in that case maybe he or she is there at the birthday party, so let's say 42. Okay, now in this case, if you definitely consider, if you do outlier calculation using either the x bar plus 2 sigma, x bar minus 2 sigma, x bar plus 1 sigma, x bar minus 1 sigma, your k could differ. Or if you use the interquartile range formula, q3 plus k times iqr, q1 minus k times iqr, most probably the father or the mother, he or she is going to become an outlier. But that doesn't mean that when you try to process the data, you're going to remove the parent out of the set of data because he or she, his or her age is an outlier. Okay, in this case, even though it is an outlier, it is not an anomaly because it is the age of the parent, it is not the age of a child. Okay, but in case, let's say that in case you get some other while recording the data, you wrote instead of 42 you wrote 150. Well, 150 would definitely be an outlier, and it would still be an anomaly. It would also be an anomaly because maybe the parent is definitely going to be elder than the child, but he or she cannot be as old as 150 years old. So in that case, maybe in this case there is a very high chance that there was some error while recording the data. Okay, because it cannot have 150 years old. So you need to have some supporting evidence. Like in this case, for the 42 case, you didn't have any supporting evidence. For this case, you do have a supporting evidence that it is not possible for someone to be 150 years old. Okay, let's say that if you are talking about lengths, okay, back in example 4 when you had all those lengths, let's say that 32 we couldn't remove out of the set of data because even though 32 is an outlier, we are not sure whether it is not possible for a snail to be 32 centimeters in length. On the other hand, if we instead we had minus 6 centimeters, okay, in as part of our data range, okay, let's say that out of our data range we had minus 6 as one of the data points. In that case, minus 6 would be an outlier because it is less than 13.4, and it would also be an anomaly. Why? Because in this case you do have a reason that minus 6 cannot be the length of a snail. Okay, you cannot have a negative length. Okay, so in those cases, as long as you can justify the reason that you are removing the anomaly, it is good. But without justifying it, you cannot simply remove an anomaly from the data. Okay, and yeah, so again, the outlier can be calculated using the sigma x bar plus minus k times sigma, or the q3 plus q3 or q1 minus plus k times iqr. Okay, and you can calculate outliers, but just because the value is an outlier doesn't mean that it is an anomaly and you need to remove it to clean the data. Okay, if you're trying to remove an outlier, by just you need to justify why you're considering it an anomaly. Okay, and once you have justified it, in that case you can continue and remove it from the data, clean the data, and continue